Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 6 of Azure Zero to Hero series, and this video is going to be very interesting because in today's class I am going to compare a real-time example, that is a secure housing society, with the Azure networking concepts that you have learned in day 5 and the concepts that we are going to learn in day 6. So please watch this video till the end so that you will never forget the Azure networking concepts. Before I start the class for today, let me quickly tell you that this is the GitHub repository that I'm going to maintain throughout this series. There will be day-wise folders that will be available. If you click on a particular folder, you can see the notes for that particular video, which will serve as a revision material. So click on the star button to get continuous updates of the changes that I make to this repository. Now let's switch to the whiteboard and start with our example. Let's say there is a real estate person and this person is interested in building a secure housing society. A secure housing society is nothing but group of houses that are built as a society and there is a proper security for that society. So the first thing this person would do is look for a land, right? And once the real estate person is able to procure the land, then depending upon the requirement, maybe the number of houses along with other requirements, the real estate person would say, let's call him as John. Okay. Now what John does is, depending upon the requirement, John will build different blocks. Okay. Let's say block 1, block 2, and block 3. Each block can be of different size and different shape. Okay, block 1, block 2, and block 3. And within each block, John would construct number of houses. Let's say John has constructed 2 houses in block 1, 3 houses in block 2, and maybe 5 houses in block 3. Now, once John creates these blocks and creates the houses, the very important thing that John has to do is secure this particular housing society, because this itself is a secure housing society. So John would come up with proper compound walls to this secure housing society and maybe place a gate and a guard to guard this entire property, so that if someone tries to access the property or go to a particular house in the property, if this person is unauthorized or if this person is an anonymous person to everyone in the property, then this person should be blocked. This person should not be allowed. Similarly, if there is a guest, maybe house 1 of block 2 is expecting a guest, then this guest should be allowed by the guard and they should help him navigate to the particular point, right? And obviously, if this guest has to go to house 1 of block 2, this person should be allowed to house 1 of block 2 only, but not house 1 of block 1. So what John would do is, additionally, there is a guard already for the entire property, but John will also place guard for each block. And the responsibility of this guard is to make sure that, okay, someone might have entered the property, but this guard will make sure the one who enters this particular block is authorized, is a legitimate person, and is expected by the guests of these houses. Additionally, if this house wants an additional security, they can also employ an additional security guard. But usually what John's responsibility is to create a security guard here, is to employ a security guard here and a security guard for the block. Now let's say guest is allowed by this security guard and also allowed by this security guard. But if the guest has to go to house 1, guest needs a proper directions, signboards, or a path. So also John will take care of path for each and every house. And also John would place some signboards. These signboards will help people to navigate within the particular block to reach a specific house. Now these are the basic things. Let's try to compare them with Azure networking. Okay, we will come back to this example, but for now, let's try to compare the things that we have learned in this example using John with the Azure networking. Just like John, there will be a DevOps engineer, and the DevOps engineers will get the request from developers or maybe management about a number of resources that they want to keep in a secured networking environment. And this secure networking environment is called as VNet or virtual network in the Azure platform. We learned that in the last class. What is a VNet? So now, how does DevOps engineer understand the size of VNet? One simple thumb rule is depending upon the number of resources that are required in this virtual network. And when DevOps engineer requests for a virtual network, then DevOps engineer will request with a particular CIDR to the Azure platform. You can learn about CIDR using the link in the description. I have explained it very detailed for 30 minutes where every concept is covered. But for now, just understand DevOps engineer requests for a virtual network. Similarly, how John has requested for a private LAN. Now John got the private LAN. Similarly, DevOps engineer has got this virtual network from the Azure platform. Depending upon type of resources, how John has created different blocks, DevOps engineers also create different kinds of subnets. Let's call this as a database subnet where database are deployed. Let's call this as business logic subnet where business logic applications are deployed. And let's call this as web subnet. Okay, let me call this as web subnet where the web applications are deployed. We're talking about a typical 3-tier application where there is a web application, there is a business logic application, and there is a database application, right? So whenever we create a virtual network on the Azure platform, by default, this virtual network is deployed on multiple availability zones that are there in that particular region. Let's say you request for a virtual network in region East US. By default, the virtual network that you get will be available in zone 1, zone 2, and zone 3 of East US. The logic is very simple. Let's say as a DevOps engineer, you have deployed the web application. Okay, you have deployed the web application in the web subnet that is created. And for some reason, the availability zone has gone down. Okay, if this virtual network is created only in availability zone 1, then the problem is that the complete virtual network will go down along with your application that you have deployed or the instance that you have deployed and all the other resources that are available in this availability zone. So that's why a simple thumb rule is that whenever DevOps engineers deploy instances, what DevOps engineers would do is create multiple copies. So if there is a critical application, do not deploy one copy of that application, but deploy at least 2 copies of the application and place one copy in availability zone 1 and another copy in availability zone 2. So that even if one availability zone goes down, there is another copy of your application that is running perfectly fine. Now, if you go back to the same example, so for this secure housing society, John has created a compound wall. Similarly, what DevOps engineer does is DevOps engineer also builds compound wall, but this compound wall in Azure terminology is called as firewall. Compound wall, security guard, gate, everything is Azure Firewall. Now it's Azure Firewall's responsibility to ensure unauthorized or non-legitimate users to enter this particular virtual network, right? So if the person is not legitimate, Azure Firewall can block the particular person. And just like each subnet has a specific guard, similarly, each subnet can have a secure guard, which is called as NS, which is Network Security Group. So this network security group acts as a guard for the particular subnet. So if I have to just repeat, just like John has procured a land, DevOps engineer has procured a virtual network. Just like John has created multiple blocks, DevOps engineer has created multiple subnets. If this is a three-tier application example, so DevOps engineer has created a subnet for web application. DevOps engineer has created a subnet for business logic application, that is the backend application, and one subnet for the database, right? Three-tier applications are nothing but there are three tiers. One is front end, one is backend, and one is database. Now, within this subnet, just like how John has created path, right? So that people can navigate within this subnet if someone has to go to instance one. Similarly, when you create this particular subnet, what DevOps engineers, when the subnet is created, there is something called as route table, and each route table has by default something called as system routes. Okay, and the responsibility of the system routes is to define the directions or how to move within that particular subnet. If someone, that is usually the request in the network terminology, if the requests or the packets have to travel within the subnet, then the route table, which has information of all the system routes. Just for your example, I mean, it's a vague example, but just to understand, probably if the request has to go to instance one or the request has to go to instance two, there are different paths, right? So those paths are called as system routes, and the one that is maintaining these paths is called as route table. So you can also create something called user defined routes, but by default, the system routes are created. Now, additionally, what DevOps engineers does is DevOps engineer create an additional subnet, and this subnet is called as App Gateway subnet. Okay, what is an App Gateway? App Gateway is nothing but an L7 load balancer. For now, just understand it as load balancer. DevOps engineers deploy a load balancer in the App Gateway subnet. That is because, I said you will create multiple copies of the applications, but who will ensure the requests are sent to copy one as well as copy two? Let's say if copy one is not healthy, someone has to automatically understand that, okay, something has happened to copy one. Probably the availability zone is down, or, copy one is too much occupied with a lot of requests. So let me send the request to copy two. If someone is accessing, let's say you are accessing Amazon.com. Okay. If million people are accessing Amazon.com at once, there has to be something called as load balancer, which will understand, okay, if instance one is occupied, I will send request to instance two. Or if instance one is down, let me send request only to instance two. So that decision is taken care by the load balancer. It is called as load balancer because it is balancing the load. And without this, if you create even 100 copies, there is no point, because load balancer is the one that decides how to send requests and to where to send the requests, right? So that's why DevOps engineers create something called as App Gateway subnet, where the load balancer is deployed. And now this load balancer will forward the request, and load balancer is assigned with the DNS name. What is DNS name? Simply, whenever you access Amazon.com or whenever you access Google.com, okay, what exactly you are accessing? You are accessing a domain name. Similarly, load balancers are given the domain name, and when you are accessing Google.com or Amazon.com, you are actually accessing the load balancer only. You are not accessing the applications. Okay, if you are trying to hit Amazon.com, That means you are accessing the load balancer of Amazon. If you try to hit google.com, you are accessing the load balancer of Google. How does it happen, Abhishek? Very simple. So obviously, when you create a load balancer, Azure will generate IP address for the load balancer. Let's say the load balancer IP address is 3.4.5.6. So what we will do is, either DevOps engineer or anyone, we will buy a domain name, just like Amazon has bought a domain name called amazon.com. For our web application, we will buy a domain name. Let me call it as Abhishek.com. And this Abhishek.com is mapped to this particular IP address. Okay. And this entire thing can be done. You can buy this domain called Abhishek.com and you can map this domain. You can map all the records in a particular service in Azure called as Azure DNS. So DNS is nothing but domain name service, and in Azure that is taken care by Azure DNS. So if from the internet there is a user, if there is some user who is trying to access Abhishek.com, so the request will go through the Azure Firewall, and even before the request reaches Azure Firewall, your request goes to your home router, and your home router will have something called as Internet Service Provider DNS, which will resolve this particular IP address. When you hit Abhishek.com, your Internet Service Provider DNS will talk to Azure DNS, and it will understand the IP address for Abhishek.com is 3.4.5.6. So using this IP address, the request will bypass through the Azure Firewall. If Azure Firewall accepts your request goes to the load balancer, and from the load balancer, your request will either hit here or hit here. Don't worry, I'll explain it one more time because I know some people might be confused. So it's a too technical topic. So I'll explain this one more time, and I'll also correlate it with the secure housing property example. Okay. So what I was telling you is, if this was the virtual network, okay, and I said this is the web application subnet, right? And within this web application subnet, what we will do is we will create multiple copies of our application. Let's say this is copy 1 and this is copy 2. Copy 1 is created in availability zone 1 and copy 2 is created in availability zone 2, just to make sure that even if one zone goes down, your another copy is available in another subnet. And who will make this decision that the request should go to copy 1 or copy 2? Or if there are 500 requests, who will make sure that 250 requests goes here and 250 requests goes here? So for that reason, what DevOps engineers does is DevOps engineers will create something called as App Gateway Subnet. And within this App Gateway Subnet, DevOps engineers will place a load balancer. And this load balancer will have an IP address. Right? By default, when you create a load balancer will come up with an IP address, but you never access websites using IP address, right? If you want to access google.com, you won't access 8.8.8.8, right? What you will access is google.com. Okay. So whenever you access any website, you access that website with a particular name, right? So this particular name which you are trying to access will be resolved into IP address, right? And this is done by DNS. So DNS is nothing but domain name service, where any name that you have, like today you can go to GoDaddy or some other thing, and you can buy a domain name. And what we will do is the IP address for the load balancer will be assigned with a particular domain name. As an organization, you can decide what domain name that you want for your web application or for your entire application, right? Let's say organization wants to call their application as Abhishek.com. Okay. So now this Abhishek.com should be bought somewhere. There are multiple things like GoDaddy or any other places, but within Azure, there is something called as Azure DNS, where you can procure this particular domain name. And the other thing that you can do is once you procure the domain name, you will update something called as DNS records. Now, I'm not going too deep into it. For now, it's not required. And once you update it, then what happens is from internet, let's say there is a user. This user can be in India, can be in Australia, anywhere. And when this user tries to access Abhishek.com from his or her browser, as soon as you type this, your request will go to your router, and your router will take this request to the internet service provider. And within internet service provider, there will be a DNS server. And that DNS server will check with the Azure DNS and will understand, okay, when you hit Abhishek.com, the user is actually trying to access the load balancer IP address. Let's say the load balancer IP address is 3.4.5.6. So now the request user is trying to enter is Abhishek.com, which is 3.4.5.6, which is this load balancer. And here we have provisioned a firewall. Now this firewall will see if this person is a hacker, if this person is a legitimate person, and if this person is a legitimate person, firewall will allow the request. This will go to the load balancer. Now load balancer can either forward it here or forward it here. Again, we have placed a security guard here, which is NSG. So NSG can also validate if the person should be allowed to access the instance or not. This is the whole logic. And this one can be compared. Like if we go back to the previous example, same thing, right? If there is a guest, and if this guest has to access a particular house, ideally, the guest will not understand where this property is at the first time. What the guest would do is open Google Maps, and this property will have a name. Let's say this property is Abhishek Properties or John Properties. So this guest will search on the internet for Abhishek Properties, or this search will search for John Properties. And when the search is performed, the guest will get Google coordinates, right? Because guest is searching on google.com. This name called Abhishek or John will be resolved to Google coordinates, and using Google coordinates, the person will navigate to this particular house. Similarly, when you try to actually reach an application, what you will do is you will search that application, or you will enter in your browser, the user will enter, ideally, the load balancer domain name. It can be google.com, it can be azure.com, it can be amazon.com, anything that you enter, that is resolved to an IP address. Just like Google coordinates, your name that you have entered is resolved into an IP address using Azure DNS and your internet service provider DNS. And once it is resolved, that goes to the load balancer. From the load balancer, your request goes to the web application. Now, why did I call this load balancer? Right? If you remember, I called this load balancer something called as App Gateway. Very, very simple logic. In Azure platform, there are two main load balancers. One is called as App Gateway. Other is called as Azure Load Balancer. The difference is that App Gateway is used for the L7 traffic, and Load Balancer is used for the L4 traffic. Okay, Abhishek, I don't know what is L7. I don't know what is L4. I don't have much knowledge on the networking concept. Very simple. Let's say you are using a two-tier application. Okay. So for your two-tier application, you will have a front end. That is, you will have a web application, and you will also have a business logic application or a backend app, right? Probably this is written in HTML and this is written in, let's say, Java, backend app. Okay. So whenever you are requesting for Abhishek.com, or let's say you are requesting for Abhishek.com/login. Okay. So initially the request that you are sending will reach this load balancer, where we will use an app gateway or an L7 load balancer for the web application, because when you search for abhishek.com/login, the load balancer will perform routing at the L7 layer, where it will look at the name, host name, and it will look at the context that you have entered, that is /login, or you might enter /logout, or you might enter /payment /transaction. And depending upon what you enter here, let's say you enter /payment, the load balancer has to forward to the, here I've just taken example of one web application, right? But usually you have web application for logout, you have web application for payment, you have web application for transaction. So if you just extend this diagram that you see here, there is this load balancer and there is this web subnet. Okay. This copy is for login. 1, 2. This copy is for transaction. 1, 2. This copy can be for logout, right? There will be multiple web applications that you will develop in your organization. And as a DevOps engineer, you will deploy multiple web applications in this web app subnet. Okay. And what this load balancer does is, if someone accesses abhishek.com/login, it will send request to either this or this. If someone accesses load balancer abhishek.com/logout, then the request will go either to this or to this. So here the load balancer that you are deploying in front of your web applications is performing routing on the L7 layer, that is on the URL that you have provided, the host and the path. This is called as L7 or HTTP load balancing or HTTP routing. So for this reason, you need to place an L7 load balancer in front of your web applications. Now, one of these web applications, let's say you have requested for abhishek.com/login. There is also a backend application. Okay, again, copy 1, copy 2. This web application should also forward the request, right? Because to complete two-tier application, your request should go from your front end to the backend. Now, when this web application forwards the request, again, it has to either forward to this or this. Who will make this decision? Load balancer. So the web application should forward the request to a load balancer, and the load balancer that you place here should be an L4 load balancer. That is Azure load balancer. Here we don't call it as Azure App Gateway, because when the web application forwards the request, you don't have to worry about the HTTP traffic, or you don't have to worry about what is the path, because this is already performed by the L7 load balancer. It has already made a decision that this request has to go to this particular web application. And now this web application is one-to-one mapped with your backend application. Obviously, login front-end application will not forward the request to the logout backend application. Login front-end application will always forward the request to the login backend application only. So that's why here the load balancer that you have should not make any routing decisions, does not have to make any routing decision at the HTTP level. It can make the routing decision, but that can be at the L4 layer, where the routing decision is made very fast, right? So that's why the load balancer that we have at the L4 layer is called as application load balancer, or just the Azure load balancer, right? That's the difference between app gateway and the load balancer. And now everything that you have here, just similar to everything that you have here, all the houses will use some resources, right? The houses have to use the water, houses have to use the garden area, the maintenance effort, and that will be charged by the John or the property. Similarly, any resource that you use in the virtual network will be charged by the Azure platform, and you can look at that billing in the Azure billing board, which I will show you when we use the next Azure demo. When we do that, I will show you how does the Azure billing work. Now let's see what are the concepts that are left. So if you go back, we discussed about app gateway, we discussed about the load balancer, we discussed about DNS, we discussed about firewall. I'll talk about WAF, don't worry. Then the topics that are left are VNet peering and VPN gateway. So here if you see, I have combined something called as VNet peering and VNet gateway. What exactly are that? Very, very simple thing. It's a very simple concept. Of course, the implementation might be slightly tricky, but to understand the concept called VNet peering, the name itself says VNet peering. That is when there are two virtual networks. Okay. As a DevOps engineer, let's say you have created one virtual network for a project called, or let's say you have created a virtual network for a project called as Nike sales. Okay. And you have created another project called as Nike billing. Okay. Probably there are two projects within your organization. And as a DevOps engineer, you have created two virtual networks. And you have deployed an application in this virtual network, that is an instance in this virtual network. And probably there is a storage resource that you have created in the Nike billing. For some reason, the sales wants to access the billing information from the storage resource. So they are completely in different virtual networks. Totally, they are in the different virtual networks. And I have told you one virtual network is secure from the other virtual network. So how does this happen? For that, Azure provides a concept called as virtual network pairing, where you have to explicitly perform, and to perform that, you have to be an administrator on this virtual network, and you need to have administrative access on this virtual network as well. Typically, you have to be owner of both the virtual networks, and only then what you can do is you can go to the routes of one virtual network and add the routing path to the other virtual network. I'll show you how to do that. Basically, we modify the route tables of the virtual networks, and using that, we will allow one virtual network to be paired with the other virtual network. There are some constraints with respect to subnets and all, but for now, we will do the virtual network peering. If we are the owner of both the virtual network, we have the administrative access. And the other thing is by modifying the route tables of the virtual network. That is by modifying the route tables of the particular subnets, right? This is how we perform combination of two virtual networks using virtual network pairing. To perform the same action, that is to allow one virtual network to talk to the another virtual network, there is another concept which we call as VNet gateway. So both VNet gateway and virtual network pairing are used to perform combining of virtual networks or making one virtual network accessible from the other virtual network. So both the concepts perform the same action, but when we deep dive in future classes, I will explain what are the pros when you have to use VNet pairing and when you have to use VNet gateway. Both of them has advantages and both of them has disadvantages as well. The next topic is VPN gateway. So VPN gateway is kind of similar to VNet pairing only, but in VPN gateway, what we will try to do is, let's say this is the virtual network of your organization, okay? And your organization is working in the hybrid cloud model, where some of your organization resources are in the on-premises, okay? Or maybe you want to make sure your office network is directly able to access your Azure virtual network that you have created. Or the easy example to understand, let me make it simple. Let's say your organization has a on-premises cloud where they have some data center that they are maintaining for some database resources, or they don't want to migrate some resources to the Azure platform. So now they want to establish connection between your organizational network and the Azure virtual network that you have created on the Azure platform. For that, Azure provides something called as VPN gateway. So using this VPN gateway, you can perform pairing between your organizational network as well as the Azure network that you have created on the Azure platform. So let's do a quick 1 minute overview before we conclude this session. If something went out of your head, let me try to compare the secure housing society example with virtual network. So the private land that John has bought can be compared with Azure VNet, right? So if this is the private land, then it can be compared with VNet in Azure. The blocks that John has built in this private land can be compared with subnets in Azure. Okay, so subnets are nothing but the private blocks. Inside this, there are houses which can be compared to the instances that are deployed. So in each subnet, you will have multiple copies of your instances. Let's say you have login application. So for login application, you will create two instances, one in one availability zone, other in other availability zone, and this pair is one application, right? Similarly for logout, you will create two instances in two different availability zones. And before this particular web application subnet, you will place, in front of this subnet, you will place a load balancer, and this load balancer is typically an app gateway, which is L7 load balancer, because whenever we deal with web applications, we usually deal with HTTP traffic, and this load balancer has to make two decisions. One is which pool to forward this request to. If user is requesting for Abhishek.com/login, so the request has to go to this pool, and within this pool, it should either go to this or this. If the request is made for Abhishek.com/login, then load balancer has to send to this, and within this, should it go here or here, right? So this is here, and then for the gated community, there will be a secure compound wall, and there will be a gateway which can compare to Azure Firewall. And each block will additionally have security guards, which can be compared to the subnet security guard, which is network security group, right? And now for each block, there will be paths, there will be routes, which can be compared to route tables and system defined routes in the Azure platform, right? So this is the basic comparison. Additionally, for each layer, there will be a load balancer, because the web application forwards the request to load balancer, and load balancer will forward the request to the application that is deployed in the business logic application gateway. From there, the request will go to a database, right? So this database will be a single database, and there will be a copy of the database. Maybe this is an active database and this is a passive database. So three-tier application logic is very simple in Azure. This is how it will work. And for everything that we are using here, the private land property owner, for maintaining it, will charge you. That is nothing but the billing concept in Azure. For every resources that we are creating, Azure will charge for the resource creation and the maintenance from the Azure side, right? So this is the comparison. I hope you understood it. Additionally, we also learned about the VPN gateway concept. We learned about VPN pairing, virtual network pairing, right? So if you have any questions, do let me know in the comment section. And finally, please let me know in the comment section, what are your thoughts about the Azure virtual network? Is it complicated? If you still find it complicated, please wait for the demonstration sessions where things will get much better to you, because you will perform the demo. Thank you so much for watching the video. See you all in the next one. Take care.